I am Anil Kumar. Welcome to my website globalmathinstitute.com and the YouTube channel. At present, there are about students from 20 plus countries who enjoy my videos. We have 20,000 free YouTube videos and more than 200,000 subscribers. It is a great opportunity for some students to join my online classes. This month, I'm taking few students who can join the group classes or as an individual. If you are interested, you may contact me on the email address mentioned here. We call it a success highway. The idea of success highway is that we provide you the foundation for achieving your targets without any obstructions. That's the whole idea of globalmathinstitute.com. Well, all school students doing math could benefit from us by the Zoom classes. We can also help you to do your homework, help you to prepare for the test, and also with the assignments. Any subject. From grade 1 to grade 12, mathematics can be taken. We are also preparing students for Olympiad. Now, let's begin with our lesson on functions today. The very first unit on functions is based on the concepts of what is a relation and what is a function. I have selected 24 test questions for you from the previous 10 years. They will help you understand about what is expected from the very first chapter on functions. Let us look into these questions one by one. I'm also going to discuss their solutions in this particular video. So the whole idea here is to share with you a quiz which is specially made for students who have taken the course on functions and advanced functions in Ontario, Canada. We'll deal with the topics called relations, functions notations, domain, range, characteristics, increasing, decreasing interval, even odd symmetry, and inverse relations. As I said, these practice questions are selected from the past 10 years of test papers. Now, let's have a look at the questions first. On the screen, you can see the first 5 questions, correct? I'd like you to pause the video, answer these multiple choice questions. Then we have the set for the next 5 questions, question number 6 to 10. You can actually pause the video, look at these questions and try to solve them. We are going to soon discuss their solution also. Now we have the next set of 5 questions from 11 to 15. So have a look at it and see how easy or difficult they are for you. In case you need help, you can always join my classes and understand more. Well, this is just the beginning. Now, the next set, we have only 4 questions here on this page. They involve inverse function also. The next set is from question number 20 to 24. These are the last 4 questions for you to look at. So you can actually pause the video at this stage, answer these questions, and then continue with the video to check your solutions. Well, you can also send an email to me on the address given here, so that will help you to get the right solutions. So if you send me an email with your attempt on this particular question set, I can provide you free of cost a feedback on your response. So let's begin with the very first question, which is, which of the following relation is not a function? Well, not a function means two things. That if we have a graph of a function, then in the graph it should pass the vertical line test, right? So on a graph, it should pass the vertical line test. So that is not a function. Is that clear to you? Now, in the first question, we are actually given the equations. So when the equations are there, then what are you looking for? If you isolate y, then you should not get plus and minus, right? So when the equation is given, you need to isolate y. That means in the equation, if you have y square, in that case, that is not a function. You get the idea? Because y square will lead to plus and minus square root on the other side, and that is why that will not be a function. So looking into the solution, we have part D, which is y square equals to 1 minus 2x. So here, if you isolate y, what do you get? You get y equals to plus minus. Do you see this plus and minus? Square root of 1 minus 2x. Since it is plus and minus, for most values of x, you will get two values for y. You get the idea. And therefore, this is not the function, and the option D is the right option. You get the idea. So within a second, you can actually answer this particular question. Question number 2. Which one of the following relations is not a function? We already have the concept. If I am going to draw a vertical line for the given function in C, it is going to cross at 2 points. Do you see that? So since it is crossing at these 2 points, it is a relation, but it is not a function. So remember one thing, that all the functions are relations. Perfect. So to summarize, a function basically means it is either one to one, right? One to one, or it could be that one is related to one, that is one way, many are related to one, that could also be a function. Do you understand? So there are two types of functions which could have these kinds of relations, many to one, right? So those will be the functions. Let me just show you what is many to one, and that is to say, if I have something like this, right, that is a function. You get the idea, right? So this is a function provided the arrows are on this side. Is that okay? So this we can say a function f of x. So that gives you the complete concept for question number 1 and 2. Now let's look into question number 3, which is, what is the domain of the function f of x equals to square root of 5 minus x? So we have to find domain of the function square root of 5 minus x. How will you do it? Well, within the square root, we should not have negative sign. That means 5 minus x should be greater than equal to 0. You basically need to solve this inequality. So that basically means that if I take x on the other side, that means 5 is greater than equal to x. Or you can say that x is less than equal to 5, correct? Which is also same as x is less than equal to 5, and that gives us the solution, which is part A. Is that clear to you? So simple, right? So that is how you'll solve question number 3. Now question number 4 is, what is the range of the function? So we are given a function which is f of x is equal to x minus 3 times x plus 4. Well, that represents a parabola with two roots, correct? So you could sketch this. So when you sketch this function, it will be a parabola kind of like this, right? So in this parabola, you have two roots given to you. The two roots are at what? Minus 1 and 3, correct? So to find the range of the function, we can find the minimum in this particular case. The minimum will be right in the middle of these two. Perfect. So the middle value here is what? It is 1, right? So you can add 3 and minus 1, right? You could add these and divide by 2 to get the middle value, right? So f of 1 is going to be the minimum. Substitute 1 here. What you get? you get 1 minus 3 times 1 plus 1, and that is equal to minus 2 times 2, that means minus 4. And therefore, this minimum point is at 1 and minus 4, and therefore the range is greater than equal to minus 4. That gives you the option C as the right option. Is this clear to you? We actually found the axis, and on the axis we found the point which represents the minimum for this parabola which opens upwards. You get the idea, right? Now let's look into question number 5, which is, what is the range of the function x squared plus 4x plus 4? Well, you could find the axis using minus b by 2a. You could do that, right? So you can find what is the value of this as minus b by 2a, or you can also factor this. This is a perfect square. So I can write this as x plus 2 whole square. That means we have a parabola which actually turns from the x-axis at minus 2. So this particular point here is at minus 2, 0. Since it opens upwards, we know that the range is going to be greater than equal to minus 2, and therefore option A is the right option. Do you see? We have understood in this set of 5 questions what is a function, how do we find from an equation or from a graph what is a function, right? And also we have looked into domain and range. The 2 examples were based on basically a square root function for the domain, and for the range we took up parabolas, the quadratic function. Clear? Now let's look into the next set of 5 questions for you. Question number 6. Which of the following function is an even function? Now, what is an even function? Can you explain me, please? Well, if f of minus x is equal to f of x, then it is even. Is that correct? That is what even is. The second way of looking into even function is that if I have parabola could be an even function, right? So if I sketch a parabola, let us say y equals to x squared. When we say even function, then it is symmetric about the y-axis. So these 2 points are same distance away, correct? So that is another way of looking into what an even function could be. So the option here is that you may look into the given answers and then figure out the correct one, correct? We know here that d is an even function since cos x is even and 1 is also even, right? So if you sketch this particular function, we know this is a cosine wave, right? This is a cosine wave which has been translated 1 unit down, correct? So it is a cosine wave which has been translated 1 unit down. So basically, it is kind of like this. When you translate it 1 unit down, then the maximum will be what? 0, right? So that will be kind of like this. So that becomes your wave, the cos x minus 1. That is how it is going to be. This is an even function. Does it make sense to you, right? So you could also substitute minus x here and then find it out, verify your answer. So I hope this concept is absolutely clear. Now let's look into question number 7, which is, on what interval is the function y equals to 3 over x plus 1 increasing? Well, the best thing here is that you can sketch the graph for this particular function. I don't mean the exact graph. Let me just sketch a small graph here in the space which we have. We have something like 3 over x plus 1. That means something like this, correct? Plus 1 will make it upwards, and 3 over x is a reciprocal function which is translated up. It is kind of like this. As you can see from the graph itself, the function is actually decreasing, right? It is always decreasing. It is never increasing. Perfect. So, on what interval is the function increasing? That is the question here, right? So the answer here is none of them, right? The answer is none of them. So it is always decreasing in the interval. So the answer actually is not provided here. So the answer here is none of them. So let me just give you option E also. So there is a, uh, let me just change this question to decreasing. Okay, so let me change this question to decreasing. Okay, now if I change the question to on what interval is this function decreasing, in that case, what is going to be your answer? Can you tell me that now? Correct? Now this is the correct question. Now tell me. So, is it from minus infinity to plus infinity, or is it always in its domain? Well, there is a discontinuity at x equals to 0. You can see that, right? So we know that x is not equal to 0. And therefore, the answer here is that it is always decreasing in its domain. Got the idea, right? So that is how we are going to answer this particular question. Now, let's look into question number 8, which is on what interval is the function y equals to x square increasing? Well, let's look into the graph which we have already drawn. So let us say this is y equals to x square. So in that case, in which interval is it increasing? Well, it is increasing in this interval, right? So increasing really means that as you move along the graph from left to right, the y value increases. Do you see that? So from 0 onwards, it increases, and therefore the correct answer will be from 0 to infinity, which is option B for us. Is that clear to you? Perfect. Now let's look into question number 9. What is the domain of the function 3x minus x squared? Now this is very similar to one of the questions we have done earlier. However, the inequality to solve is slightly more difficult, and that is why I have included this question also here. Now I'd like you to pause the video, answer this, and then let's look into the solution. Well, the concept is clear. 3x minus x squared should be greater than or equal to 0, right? So that means 36 should be greater than or equal to x squared. Now if I square root both sides, then what happens? That is the critical part. So when I square root, what is square root of x squared? The square root of x squared is absolute value of x. You get the idea. So, absolute value of x should be less than 6, and that becomes the answer. Both being included, and therefore option D is the right option. Do you understand that? So, major issue here is that many times students do not understand what is square root of x squared, and they make a mistake. Perfect. So that becomes the answer for question number 9. So I hope you understand how we are moving gradually from the very basic concept of relations and functions to domain and range. Now these are excellent questions for any student who begins with this particular unit, right? Now, question number 10. Can you please pause the video? Answer this question, which is what is true about the function y equals to 1 plus x square over absolute value of x? Is it an odd function? Is it an even function? Is it a continuous function? Or is it always increasing? Right? So, when you work it out, you will figure that this could be an even function. Since all the components here are even, x square is an even function, right? So we have x square which is even, absolute value of x which is even, right? And plus 1 means we're just moving it up by 1 unit. So that keeps it even. So this function has to be an even function. You can actually verify the answer. If you write y as minus of x, then we know 1 plus minus x whole square over absolute value of minus x is equal to f of x. And therefore, it is an even function. So I hope this concept is absolutely clear. Perfect. Let's move on and take the next set of questions. Question number 11 for you. So I like you to pause the video, read question number 11 and then answer. Perfect. Which characteristics is same for the two functions y equals to 1 over x and y equals to sine x? So I'd like you to pause the video, answer and then look into my suggestion, right? That is sine x, correct? So, and 1 over x is kind of what? So let me draw the axis here. I'm just giving you time to understand and answer this particular question. Is that clear to you, right? So I'm drawing 1 over x also here. Can you tell me how are they similar and what is their similarity? Well, both these functions are odd functions and that is the similarity. We know sine of minus x is equals to minus of sine x. That is why this is odd function. That means f of minus x is minus of f of x, correct? And therefore this is an odd function. So as you can see, the odd function is symmetric about the origin, right? So let me write down here, odd function is what, right? So odd function is symmetric about a point, and the point here is origin. So that becomes the odd function. And the second way is algebraically f of minus x is equals to minus of f of x, then the function is said to be an odd function. Is that clear to you, right? So that is how we'll actually define the odd function. Perfect. So let's move forward and now take up the next question, which is question number 12. Which question is not quadratic? So that is relatively a simple question. Quadratic means a polynomial which has x squared, right, as the leading coefficient, leading term. So this is x squared, x times x is x squared, 2x squared is clear. But here if you multiply, you do get x squared. However, this part which is a restriction, x cannot be equal to 0. It is in the denominator. It's a reciprocal function. So that doesn't make it quadratic, right? So option C is the right option for question number 12. Can you now please read question number 13 and answer? Consider f of x equals to 6x minus 2x squared and g of x equals to x squared minus 9x plus 1. Which of the following is true? So you need to look into this, solve, and then find the answer. So what you should do is substitute each set of values and then figure it out, right? So substitute minus 3 for x in both the functions and then find the answer. Similarly, you can substitute 4, 0 and minus 2 to check your answer. Now both are quadratic functions, so this might take time. So you need to substitute and get your values. Is that clear to you? So calculate the solution. Is that clear to you, right? So calculate and then find the solution. Now the questions hereafter, what I'm trying to do here is trying to tell you the ways of solving. You can solve these questions, submit your solution to me, send an email, right? So in case you want to have my feedback on your solutions, I'll provide that free of cost to you. But you can always uh, write down as comments where I'll reply to your comments also. And you can also join my classes to learn more. Fine. Now question number 14 is very similar. It has to evaluate f of x equals to 7 minus 4x squared for f of 1 and f of minus 2. So just substitute 1 and calculate, right? So substitute 1 here in the equation, you will get 7 minus 4, and then substitute minus 2. You get 7 minus 2 squared is 4, which will give you 16 minus 7 minus 16. Add them up and check your solution. Is that clear to you? Perfect. Question number 15 is given f of x equals to k times 4 plus x, find the value of f inverse minus 3 equals to minus 5. So you need to find the value of k so that the inverse function has to be satisfied. So look into the strategy involved. I can always explain you how to do this question within seconds. Perfect. That's the whole idea. So you can actually send me an email to understand these solutions. Similarly, the next four set of questions, which are slightly more difficult than the questions which we have done, I like you to attempt them and then share your solutions with me. We're talking about inverse of the function here. So let me tell you what inverse of the function is. So if we have a function, which basically a rule, right? So if you have a function in which we provide an input x, we get an output, which is f of x, correct? So that is the function. The inverse is the reverse operation. That is to say, this inverse will return us the value of x if we provide f of x as the input. So the reverse operation, is that clear to you, right? So when you do inverse of a function, you get x back. So you start with x, right? So you start with x and then you get f of x. That is called the function, right? Now the inverse of the function is that when you feed in f of x, you get x. So that is what inverse of the function is. Based on this concept, we have 4 questions on this particular page. I'd like you to pause the video, answer these questions. You can submit your answer in the form of an email or as comments in this particular video. Now, there are last 4 questions to you. What does f of x represents, right? Figure it out. Is it just a value of independent variable? Or is it a range of the function? Or is it value of dependent variable, domain of the function? So you are given the 4 choices. The whole idea here is to share with you some very important questions which we have seen over the past 10 years here in Ontario, Canada. So if you like this set of questions and if you like my way of teaching, you can always join our classes. Perfect. So I hope with this you got a glimpse of what we can offer you. Feel free to write your comments, share your views, and if you're really interested, then I'd like you to join my classes and learn more. We can go with you along with the school also, right? So let us say there are 9 units which you cover during this semester or quad semester during the COVID time. Be rest assured that if you are guided by me, there are no hurdles. It is success highway. Not only for the students who are doing functions, but any student in the school up to grade 12 who wants to understand mathematics and attend some math classes and is looking for admission to prestigious universities can join my classes. Simple guidance can make huge difference in your life, and that is what I'm trying to say here. Thanks for your time and all the best.